I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Autonomic Cybersecurity. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A couple of administrative notes before we begin. All phones have been muted except for the presenters. Questions may be asked anytime during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the presentation. And I'll also like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our presenter for today's webinar, Dr. Salim Hariri. Salim is a professor in the Department of Electrical and Computer Engineering at the University of Arizona. Dr. Hariri is the co-director of the National Science Foundation Center for Cloud and Autonomic Computing, as well as the founder and CEO of Avertech, Inc. His research interests include cybersecurity, modeling and analysis, resilient cyber resources and services, and high-performance distributed systems. Salim is also the editor-in-chief for the Cluster Computing Journal. I will now turn the presentation over to Dr. Hariri. Good morning, Salim. The floor is now yours.
Okay, good morning, afternoon, whatever the time zone you are in. Thank you very much, Steve. It is my pleasure to basically give you an overview of our autonomic cybersecurity activities and projects. As Steve mentioned, I have two hats. I'm co-director for the NSF Center on Cloud and Autonomic Computing that involves University of Arizona, Texas Tech universities, and we are in the process of adding more schools like Virginia Commonwealth University, University of Detroit, Mercy, and University of Colorado. And next month we will have an international site in Mexico. And Avertech is it's a cybersecurity spin-off from the center, our center. So today's presentation is really joint activities between the Avertech and the center. So a little bit about the center. It's a multidisciplinary center that try to engage industry, academia, and government to pursue short-term research goals and objectives. It's not like a basic research where the activities span 5 to 6 years. It is within 1 to 2 years span. So that is our center. So it focuses mainly on applied and challenges that industry government are facing, and we try to address them by engaging students, multidisciplinary research teams. And we also support the startup companies or any technology developed in the centers. We'd like them to be commercialized, and Avertech is an example of that. So what is the benefit for industry or government? Basically, the nice things about the centers, because we get the operational funding from NSF, so any membership fees will be almost free of overhead. It will be reduced from 60% to just 10%. And you will be able to collaborate with faculty, graduate students for whole 1 year. And also you would be able to select the project that you like the center to work on, and also being a member of a national center. So any project carried at any site is really your project. So in the center we have like ongoing research in cybersecurity and the approach we are following at University of Arizona and Evertech. We call it Autonomic Cybersecurity, which is the focus of today's presentations. And we have ongoing project in big data analytics and high performance. But today's I will just focus on the autonomic cybersecurity. So I'm sure everybody is aware of all the challenges cybersecurity, and anytime you read the news articles, watch the news, you hear about cybersecurity. So, and this is one slide because I want to focus on our approach. Just summarize the challenges that we are faced with. It's like, how do you respond in a timely manner to complex, fast, propagating cyber attacks that they can reach the whole internet in a fraction of a second? And also, insider threat, it's a huge problem for us because you could have somebody managing your networks, your computer resources and everything, and in a fraction of a second, he becomes against you. So how would you protect that against it? And then we reach the point we reach in building computers. Before we said we want to build computers that never fail. Then we realized that's an impossible task to do. I believe we are reaching the point where cyber systems are going to be successfully attacked and penetrated. And then for mission critical applications, the question is, can we do what we did in the computing field? We build fault-tolerant computers. Can we build resilient cyber operations or systems that can tolerate attacks even if they exist? So these are really the main challenges, and the current solutions, as we know from the media that we hear every day, they are basically ineffective. They are manual, and they have many isolated tools. They don't talk to each other, and they really lack the use of biometrics as an integrated in the other solutions. So our approach is really a paradigm shift in how you address cybersecurity. We call it autonomic cybersecurity, and I will try to convince you that this is the paradigm that we should adopt and follow. Because I always say to my students, if you go on the wrong path, and you continue doing that, you will always get wrong results. And we are spending $40–50 billion a year on cybersecurity, and the solution doesn't work. So we should really take a different approach, and that's what I'm going to advocate in this presentation. So autonomic cybersecurity, it has two main components. One, we call it full visibility. So that means at any instant of time, if you want to know what the network is doing, what user X is doing, or applications or device, you have full visibility into what's going on. It's basically full situation awareness. And the second, because of these fast propagations, so we have to do continuous monitoring, analysis, and mitigation so that the moment something goes out of the norms and the acceptable policies, you can act and mitigate in immediate time. So as you can see with these capabilities, by having full visibility, so you can see any things going wrong immediately, and you can act on it. And if the insider threat, for example, was for you and suddenly becomes against you, because I'm doing continuous monitoring, analysis, and mitigations, I can immediately respond to that change. So that basically in the cybers, we have to assume everything is malicious until proven it is not. It's the opposite of the legal system here. But I will elaborate in details in 2-3 projects how we do this. So let's look at why the current cybersecurity solutions fail. Most of the techniques that are commercially available, they are basically signature-based. What signature-based in the simple terms? It means you really know what the bad guy is going to do and the mechanisms they would follow, and you build a signature for it. So, but if that signature is really executed as it is, you can easily detect and implement. But the problem is, as we know, it is an impossible task to know what the bad guy is going to do. So this is the wrong approach, and that's why the current cybersecurity solutions we have today doesn't work. The other approach, you reverse that. You say, I'm not going to assume I know what the bad guy is going to do. I'm going to assume I know what the norm is. That is reasonable assumptions because we can figure out what the normal behaviors, and medicines is a good example because all the doctors, all the medicine, what they do, they basically diagnose and treat us based on their knowledge of how this organ should behave. The problem in these, so it can detect any attack, whether known or not known. But the problem we have with the anomaly is that it's a high false positive. And the reason we have high false positive is like this diagram captures it, because our network is so complex. There are so many protocols at the application level. There's so more protocol at the reference point, and then for all of these to come up with an anomaly detection, intrusion detection system to detect that, it's impossible. That's why we end up with a high false alarm. But then how did our body is as complex and more complex than this. So how did medicine do that? Well, they did that by creating specialists. So, like there's no one doctor can understand all the physiology of our body. So they create cardiologists, allergists, internal medicines, pediatrics, and so forth. So that means we will have a specialty to focus on one area of organisms in our body, and the doctor will spend 3-4 years just to learn the norms for that organism and then becomes a specialist. Our approach is exactly that. It's an anomaly based, but we have what we call micro-intrusion detection engines, or you could call it a specialized intrusion detection engine. So that means for every protocol, every box that you see here, I'm going to have an intrusion detection that could spend a year or two, try to understand the semantics, the behaviors of that device or protocol, and then come up with a specialized intrusion detection system for that. We call it micro-intrusion. So that is the approach that we are following, and I will highlight it more as we move along. So then the approach that we are taking in Evertech and University of Arizona is the Autonomic cybersecurity. And I would, our approach, as I indicated, is really inspired by the human autonomic nervous system. So that means now I'm giving lectures, but my nervous system is regulating my blood sugars, heart rate, breathing rate, so I can give these presentations, but I'm focusing on really ACS now. I'm not focusing on my blood sugars and heart rate or breathing rate. The nervous system in a seamless way is doing that. So ACS is trying to follow that analogy. So the ACS is basically continuously monitoring, analyzing, and diagnosing the user's cyber behaviors systems. And if I see any violations of the normals, acceptable security policies, so proactive actions can be taken. So that is the analogy to the human nervous system. So let's dig in more into that. So how we build that capabilities, as you can see. So I start with my cyber infrastructure. So I define cybers. It's like your physical resources. I call it infrastructures, your data, your applications, your users, and some community. So I have a continuous monitoring of the operations and the behaviors of these. And then I come up with specialized data structures. I call it a resource cyber DNA. So the reason I'm using the DNA is that I'm going to spend whatever time it takes to figure out exactly how this computer, how this network router should operate in a normal way. And I build models, runtime models that can be efficiently executed with low overhead at runtime. So it tells me if this resource is behaving normal or not. And the same thing for data. So if I have data files or repository, and I look at how the data and the cyber include all of these, how the data is interacting with the rest of the cyber resources, and I create a normal runtime model that captures that. I call it data cyber DNA. And I do the same things for the applications and the users. So as you can see, I do continuous monitoring. I build innovative data structures that help me decide if these resources or data or users are behaving normal. And then I have a big data analytics engines that can decide in very timely manners if any of these resources not behaving normally. Then I would generate alert, and then based on the alert, the policy, I can take an action. As you can see, it's like the nervous system in our body. It's a continuous closed control system. So we monitor, we build data structures to help me decide on things in real time. And then I analyze. If I see a problem, I take some actions. So that is the ACS methodology that we are basically building through several projects funded by NSF, Air Force, Navy, Army. So, and I will talk about this. So this is just an example of what we mean by user cyber DNA. If I have a user, so I create that data structures. Then I look at the user behaviors with the biometrics. How is this user using the mouse and the keyboard, or is there any deceptions in that user? So let's say somebody log in as Hariri to my account, figure out a way to penetrate and says, I am Hariri. But then if I look at the way he or she using the mouse and the keyboard, and if I ask questions and they answer, so I can see this is not the biometrics that I have for Hariri when he used the keyboard and the mouse. Then I look also at the application software's behaviors, the data access pattern, the resources, the network. All of this collectively, really you define uniquely how I interact with my cyber systems. So any violations of that, I can immediately detect it. So this is a very powerful approach for the insider threat. If you have an insider that's doing network activities that not supposed to do, or data access or application or reason, and then if you ask questions, and then you could detect some deceptions in that. So if we look at, so the idea then of continuous monitoring, so we basically build n-dimensional space. And as you can see, every dot here represents your current state, where you are. If you remember, I said the ACS approach has two main features. One is full visibility. So at any instant of time, I know where you are and where you are heading. So let's say you are here and there, and then I know after sometimes you will be heading in this direction and you get outside the normals dimensions that I want you to stay there. So that is the beauty of the anomaly and building data structure that uniquely identify your current state and where you're heading, and that gives me the ability to take some proactive actions. And then once I see some anomaly, so I have, like as we discussed, we observed the behaviors of the managed resource, and we have the behavior analysis. So we know at any instant time where you are heading. And then I have a controller. Once I see some anomaly, I can take some actions like lock the computers, log off the user's reboot, and so forth. So it's basically continuous monitoring, analysis, and taking some actions. So in order to do anomaly behavior, you need to understand what the norm is. And to understand the norms, we have to build a testbed that help me understand how this protocol works, how this industrial control, SCADA system, Modbus, DNP trees, if I have smart buildings, how the technology, wireless. So we basically have a unique testbed for all the technology that you might see in the cybers. And what we want to do, we need to analyze their normal behaviors and come up with the runtime model that captures any anomaly behaviors. As you can see, we have smart homes, smart cards, National Instruments, smart grid technology. All this help us build the runtime model that we need in order to detect any anomalous behavior and take action. So basically to build the ACS capability we did. And we are in collaborations with Mitsubishi to analyze their AutoInfotainment systems, identify all the vulnerabilities that exist in that smart car, and basically try to mitigate them. So in these presentations, I picked a few projects to talk about. One is I call Tactical Cyber Immune System. And we have, it's a part of an STTR phase 1 between University of Arizona and Evertech, and we have an Autonomic Monitor Analysis and Protections, AMAP. It's a phase 1, phase 2 SBIR between University of Arizona and Evertech with the Air Force, and we have a Navy project. It's about adaptive big data trend analytics, and we are in collaborations with Raytheon to build an intelligent cybersecurity assistant. And we have other ongoing projects. I will try to touch briefly on each one and show you how we apply the ACS into these projects. But if you are interested in any one of these, I'll be happy to provide you with more details about each one of these projects. So as I mentioned, the Tactical Cyber Immune Systems, it's with Surdex in the U.S. Army. It was a collaboration between Evertech and the center at the University of Arizona. So the idea of the TCIS is to build like nervous systems, an analogy to the B cells and the killer T cells and the memory cells. So we want to basically build systems. We call it a cyber immune system, and it's designed for a tactical environment. And that is the analogy between the immune system and the human immune system, and this is the analogies of that. But after the phase 1 of this project, we were able to build a prototype, and that's what I'm going to emphasize on. So basically to determine any behaviors of the users, apps, servers, protocol, devices, if they are behaving normal or not. It's like the B cells. The B cells need to detect anything that's abnormal. So we build what we call self-recognition flows. It's like in the network we have NetFlow or S flows and we have A flow. So idea is to look at the behaviors of these users and come up with a data structure that help me decide if this is behaving normal or not. And then I have the self-recognition agent, the SRA, that once I feed this data about the behaviors of all these entities, I can determine if this users or this app or this server behaving normal or not. And once I determine that any one of these is violating the normal behavior, so I have what I call self-protection agents, the SPA that can take some actions based on severity of the violations and all of that. So as you can see, this is a good examples how to apply the ACS methodology. Through these observers, we observe all these entities and build data structures. And then we build data analytics to help me recognize any violations of the norms. And then if that is the case, based on some knowledge, we ask the controller to take the actions against the user's app and protocols. So we have built data collections and methodology for that. So the data analytics, basically we collect data and then we look at principal component analysis and to come up with the norms, and then we take some actions. Like this is samples of users monitor data. So we collect all the users' activities, and with that we build this is samples of the applications and the host monitor data. So we monitor a lot of this, and then with data analytics, I can identify the most relevant features of characterizing the norm and abnorm, and these are the ones we use. But initially, we collect a lot of data over a long period of time, and then we build these models. And in the phase one, we build some metrics to evaluate how accurate, like the accuracy, the precision, the specificity. So we have built sophisticated evaluation techniques to look at how good is our approach. And so this is the results for a self-recognition agent trained on the application. As you can see, the detections is around 99%, the specificity, the precision is 100%. It's a very accurate result, and the same things with the users. We said I'm looking at Hariri's active users, and then if somebody comes in and says I'm Hariri, I would be able to identify that with the high detection rate. And we did the same things for computers. So it's any computer that I have runtime models for how this computer should be used, and any violations of the normal policies of that computer, I would be able to detect it with 100% accuracy. So we have built a prototype, and we applied the ACS methodology all the way from data collections, building the data structures, doing the analytics, and validating the approach in this prototype. The other project is really very interesting. It's a phase one, phase two SBIR with the Air Force Research Lab in Rome, New York. The idea is that can we have an autonomic monitoring, analysis, and protections? We call it the AMAP. But this project is just focusing on the data issues. So before we focus on the system, cyber, from computer users, networks, applications, and so can you apply ACS for that and build a tactical cyber immune system? This project is really simply put it, you have many data files in any classified environment on the internet, can I move these to the classified environment so I can use them for my analysis, for forensic analysis? Of course, to move something from unclassified to classified, you really want to make sure this file or this audio, this image is malicious free. So that is the AMAP project, is that you give me any files, any data types, whether it's a PDF, HTML, image, audio, and the question is that has any embedded malicious or not. So what we do is that we do two types of detailed analysis. One we called Anomaly dynamic analysis. We take that file and run it in the sandbox virtual machine and isolate it and look at all the behaviors, interactions with networks, memory, and system calls, and see if any of these, it could have an embedded obfuscated code that with the structural analysis you cannot detect it, but at runtimes there's nothing can be hidden because I'm looking at the zeros and ones execution traces at runtime to decide if things normal or not. And I also have what we call the structural analysis, where I look at the metadata, the structures of the files, and see if there's any embedded malicious code. And then based on these two analyses, I make a decisions whether this file is secure and normal, and if it is, we can move it to the classified, or we identify the malicious component and we recommend some actions. So like this is the dynamic analysis as I mentioned. So we take the, we build the sandbox, and we build like this one show you the DLL, all the system calls or all the executables object that calls. So I create a trace of that and I analyze them. It's a very sophisticated and accurate dynamic behavior analysis. So I believe we are the only group in the country that does that detailed dynamic analysis. So, and the, for examples we have done in this project, many different data types, HTML, XML, RTF, image files, and now we are doing the audio, and we built a prototype, and we are really looking for sites, because this is a phase 2, and we would like to go to phase 3 and deploy that capabilities and potential site. So I'm going to show you some of these examples of that. Like an HTML file, you could have a malicious code in a hidden frame that you cannot display it, but because of the width and the height is just 1 pixel. Or you could have a malicious reference to site, or you could have hidden or misplaced. So these are some of the known attacks that can target the HTML file. And as I mentioned, we build malicious, we build a static analysis approach for that. And so this is, just to give you an example, this is a normal HTML file when we do the structural analysis. When we look at the structural analysis, you see this is usually, we don't see it in hundreds or thousands of HTML files we studied, so that will tell me this structure is abnormal. And the same things in the dynamic analysis. So I look at the way you move from this executable to this executable. So all these finite state machines with the green arrow represents a normal transition. But I never see transition from this state to this state. I see it only in malicious files. So that would trigger the dynamic analysis. There's something abnormal there. And we have done a lot of detailed static analysis to prove that our approach is very accurate with the different data analytics classifications algorithms. So we have a lot of results. If anyone interested, I could share this result. As I mentioned, we built a prototype. Now you log into that system, and you could upload the file from the internet, or you put it into USB, and then we could analyze the structure, the dynamic, and tell you if this file is malicious or not. So this is just dump screens from that. The other project, which is a Navy project, it's a STTR Phase 1. Again, it's a collaboration between University of Arizona and Evertech. We call it Adaptive Big Data Trends Analytics. So this is a really important project because we all use data analytics and machines to build some models. The problem is that we assume that the data that we use for trainings are fixed, doesn't change. But that assumption is really not practical at all nowadays. Your data that you use for trainings a month ago or a week ago, it's not valid anymore here. So the question is, as the data change, can I detect that the data I used to build the model has been changed? And if the data changed, can I adopt my machine learning and data models to reflect this new change? So that is the project. We just finished 5 months of development. And so the idea then is to develop framework that allow us to build both active and passive forms of learning and detect the change, and then when the change is detected, what would be the right data model for it. So as you can see, the project has 5 tasks. Task 1, can I detect the change in the data? Can I learn lifelong learnings? So as the data change, I adopt my models, and can I use hybrid? And the interesting part, we are using an artificial intelligence to basically come up with the recommendations in an automated way, because we don't expect the users to be really an expert in data analytics and data scientists. So we want to use AI capabilities to basically take all this knowledge that we did and build an intelligent recommender systems that detect the change, recommend what things need to be done. And this is how we build it. As you can see, it's very similar to the ACS methodology. So we get all this data, and then we have a model to detect the change, and we have a model that does a lifelong learning, and then we have the behavior analysis that help us do the recommender systems, basically to tell the users what kind of models should be used as the data change. The last project I would like to highlight and then leave some time for question and answers is what we call Intelligent Cybersecurity Assistant. So again, like if you take an enterprise, so you are talking about 200,000 people, 400,000 assets, many servers, petabytes of storage. It's a huge complex problem. And if you look at the network analysis, they get thousands and hundreds of thousands of alerts on a daily basis. And then they have to manually analyze all of these alerts and then decide what kind of course of actions I have to do for each alert manually. So that's an overwhelming task. And as we learned from the beginning that these cyber attacks propagate super fast. So we really don't have the time to analyze all these alerts. They are coming from different monitoring tools, intrusion detections, prevention, and decide on that. So the question is, can we build an intelligent cybersecurity systems like Siri, so that 24/7 can analyze what's going on, put all the cybersecurity knowledge, and take an action. So that is the ultimate goals of this project, is we call it the ICSA. So the idea is that so we continuously monitor your assets, risk assessment, manage. We identify them. We know what resources you have. And then we apply all the anomalies that we talk about, or any tools that you have to detect any malicious activities. And then based on some knowledge to protect, so we can take some action to protect, recover, and respond. And this all, it becomes your robot cybersecurity assistant to you. So the network analysis could say, you know, for this asset or for this malicious event, what course of actions we could take. In fact, we are building voice recognition capabilities. So we don't want the network analyst to interact with ICSA by typing. We just says, you know, I see this anomaly. Can you tell me how to basically recover from it, what I should respond to it? Then the ICSA will look at all the knowledge, all the analysis, and give you the answer. Similar to Watson's and any intelligence system. So this project is in the early stages, but I just thought it's another technology we need to promote and support, is how we can use artificial intelligence and recommender systems and all the cybersecurity tools that we build to help the network analyst detect and respond and recover in real time with less work on the analyst. And as I mentioned, so we can use exactly the same methodology we did for the ACS. So we can use our DNA data structures to identify the current behaviors, and then we use our anomaly behavior analysis to detect anomalous behaviors on resource data applications. And then we have an intelligent recommender systems that could be based on Watson's, IBM, that we could build hypothesis that says, I see this alert. I would think it is advanced trust persistence, and then what are the evidence and what do you recommend I should do, and then I do. So, and then we have all this trainings, knowledge, corpus that we built that the recommender system would use. Ongoing other projects, and I will stop. We have a cybersecurity lab as a service. When we teach cybersecurity in the university, we couldn't really build physical cybersecurity labs. So we basically virtualize it, put it on Amazon, and our students log into Amazon AWS and build all their cybersecurity experiments there. So this way we can support hundreds of students. In fact, a couple of weeks ago, we had 120 students from University of Lyon in France. They were doing cybersecurity lab works on our Amazon site. So they can do DNS attacks, cross-site scripting, buffer overflow, DDoS experiments. All it's done on that. And in fact, this semester, our students are exactly doing that. Now they are doing the DNS experiment. It's due this Thursday. So that we have also ongoing project is that your adversary, they know that you're using machine learning to do that. They might inject some data to noise, and that will basically allow your machine learning to learn this adversary data, and basically would reduce your detection rate from 90% to 50%. So that's how we can make sure that if we have an adversarial data coming in, how we can detect and protect. Also, we have an SF project to look at the hackers and see what they do. In fact, WannaCry malwares, my students was monitoring hackers' site because we have bots that monitor 24/7 the IRC messages exchanged with hackers. In fact, 1 month before WannaCry launch, we were able to see exchange messages among the hackers how to launch it. Unfortunately, we didn't have the means to report that, but that's something. And now we are working on identifying the authors of any. Let's say if you change your name from user X to user Y to user Z, by looking at your IRC messages, we can identify that you are the same user. So the last project is cyber deception engines. So the idea is to build lie detectors. They can look at your eyes and your voice and your body biometric to see if there's deceptions or not. We are trying to do the same things, build cyber deception engines so we can have cyber visibility, cyber hesitation, inconsistencies, intensity, and so forth. So we could build analogy like what we did with the tactical cyber immune system that helped me determine if there's any deception or not. So with that, I hope I convinced you that we should really support the autonomic cybersecurity paradigm that is proactive, that is based on Anomaly and with the specializations. And I'm now open for any questions that you might have. Steve?
Okay, yeah, thank you for that presentation, Salim. You're definitely doing a lot of interesting work at the center out there, and you kind of indicated in the in the work that's been done in the past, the signature-based oriented. We haven't really had a lot of success in that. We always seem to be one step behind the attackers. They find the vulnerabilities and exploit them. And then we're left to try to patch those gaps. So, your approach here seems to be, more proactive. I mean, if there are potential problems, I mean, you're kind of developing the systems to be more resilient. So if an attacker does kind of get in, you're looks like your approach may be more successful at minimizing, containing that damage. So I just wanted to say I think you're
Yeah.
on the right track here and moving in the right direction. So
Thank you, Steve. Yeah.
Let's see. So I did. So I've got a couple questions, and we do have some from our audience. So you mentioned the micro intrusion detection systems that you're proposing, you're developing. So I'm kind of curious,
yeah.
How many of those are typically developed, deployed? What kind of, what's their size? What's the kind of overhead? Are they like intelligent agents that interact amongst themselves? So I'm just curious if you can, maybe tell us a little bit more about that.
Yeah, they are really, because we do a lot of works on the background to identify the right features and how these features behave over time and space. So we were able to condense the overhead to be applicable at runtimes. We built basically specialized behavior analysis for TCP, UDP, IP, MAC, DNS, Wi-Fi, HTTP protocols. We built for Modbus, DNP3, BACnet. So, and now we also build it for Bluetooth and Zigbee. So we have build all this, the same methodology applied, all of this, and the overhead is really very little.
Okay, great. So one of our attendees had also a question on that topic, but they were wondering how they worked, say, in contrast. In the past, the individual is talking about products like the network flight recorder. Are you familiar with that, and how that would compare to the micro intrusion detection system?
I'm not really familiar with that, but I don't feel they do the fine-grained anomaly behavior analysis that we do. So I stress the analogy with medicines to emphasize that point. You know, like to be a cardiologist, you could spend 10 years, 6 years, 10 years to become a cardiologist. Like for my students to do the DNS, he had to do whole PhD dissertations to be expert on the DNS and build that runtime models. And the same things. I have one PhD student, all his PhD was building a Wi-Fi 802 and variations of that. So I don't think the industry today, whatever project, they go that deep in their behavior analysis the way we are doing it. And the fact is just we are not successful against the bad. And if there's any technology that is proven, it would be deployed everywhere.
Yeah, so kind of like you're saying with that medical analogy, you know, that kind of, you know, you've got the one guy that really focuses on a particular system and does the deep dive and, you know, becomes an expert in, you know, all the activity there, and so that's kind of the approach that you're taking with your
See, like
method
the current
so.
industry, the current industry and practice, Steve, exactly that. They said, okay, I'm going to spend a year and I'm going to build an anomaly for all the protocols of all the computer systems. And it doesn't work either. There's no way you can build a solution that can be deployed in real time with a little overhead with that many. Because I showed you that diagram that shows you how complex our cyber systems are, from protocols, from this. To say I'm going to spend a year into that doesn't work. But if you tell me like what I did with my students, I told them, okay, you're doing the HTTP protocol. I want you to spend 2 years doing nothing other than studying all the messages, all the interactions in the HTTP protocol, and then tell me how we can do semantics and data analytics to do the anomaly. I think that is reasonable after 2 years studying this or doing the DNS and all. That's what you see. When I mentioned, you asked me, Steve, the question, what kind of specialized intrusion detection? Every single protocol is either a master or a PhD dissertation.
Yeah, and that's, you know, a great great description of what, you know, what it takes, and really, you know, in out in industry, really not going to throw a body at a problem like that for 2 years to, just the nature of the system. That's not going to happen. So with universities and academic research centers, that's where you can really do that deep dive and get down to the nitty gritty and come up with some valuable information. So so that's good stuff that's going on. So so one of our attendees has a question about the so he kind of got the feeling or the sense that the work you're doing is better suited for large scale type enterprise systems. Is that kind of like where this is targeting, or do you see this could be potentially deployed kind of on our desktop type of system? And if yes to that, when might that be? How and when might that happen?
Yeah, in fact, this is a good question, and thank you for, our solution is really scalable, but the commercial deployment of this technology, we have products, we call it AIM. It's an automated and integrated management, and you could see that product on the Evertech product website. And the plan is next month to start deploying it commercially at larger scales. For small, to small, medium. In fact, we built a system we call the Cyber Expert System, like Siri, that you can go to the cloud and then download it on your computers, laptop or desktop, and then you will have all the our anomaly behaviors to protect your computers and your local area at home or in a small office. So initially, in fact, we are targeting small, medium size, and we have deployments of the AIM systems in Tucson, in Washington, D.C. areas, in Dallas, Texas. And we have, for 2 years, we've been protecting our labs using our AIM technologies, and Evertech is also using the AIM system technology to protect that. Yeah. So the questions, send me emails. Hopefully next month we will start large-scale commercial deployment of that technology for small, medium networks. We have already deployed these capabilities for more than 2 years now in small, friendly sites.
Oh, that's great. Great to hear that. You've matured the technology to that point where you're actually getting it deployed out in the real world. That's great. That's awesome to hear. That's so kind of maybe a little follow up on that question. Another individual is curious as to what kind of increase in resources would be necessary to implement these solutions, to include maybe the type of equipment or people needed. So do you have any thoughts on that? Is there a lot of extra required to utilize your approach here?
Not really. Like as you saw from the titles, is autonomic, and being autonomic, that means you do self-protect, self-knowledge. And the latest work we are doing, we are adding an intelligent systems and intelligent recommender system to basically eliminate the need for highly specialized people. And so, in fact, our solutions require less. And because we are doing this autonomic, one of the problems we have in getting IT companies for small business to accept our technology, because they feel we are eliminating their jobs, because we are automating all the IT, the cybersecurity jobs. And that was one of the biggest problems we had. In fact, then Evertech created an IT company just to deploy that. So that's how we managed to deploy it in Tucson, because we have an IT company that, because if I go to IT company managing, they feel it is, it's basically jeopardizing their job. I keep telling them it is not. It is just making your job easier. So you can, instead of handling 20 clients, you might be able to handle 100 clients with our technology. But just it's so hard to penetrate. But we are, because of the automations and using commodities, so our solutions is much cheaper than what Cisco and Juniper's offer. So we feel we'll be successful once we start deploying it commercially.
Yeah, I think it's probably kind of that cultural. I think they need to have a better understanding of how the system is going to help them. This isn't one of those cases where they'd be getting replaced, but it's not
replaces.
Kind of.
Yeah.
Yeah, it's kind of there's so much information and data coming in. It's kind of filter out the noise and pulling you're trying to pull out the things that they really need to pay attention. And it's like, here's the problem. Look at this. This is where you need to look. And there's always going to be problems. There's always going to be problems. So,
yeah, that's exactly this. But the problem, they see it, I'm eliminating their job,
Right, right. So, I think I'll throw one more question at you, Salim, and then we've kind of past our normal time, so I'll hit you with one more question, and then we'll wrap it up here. So,
okay.
One of our attendees was wondering if you happen to be participating in any kind of standards development activities, and if so, is that trying to get that flowed out to industry, or is kind of what you're doing kind of really tied to your can't be standardized, it's more specialized than standardized, I guess.
Yeah, like we have ongoing project with NIST, the National Institute of Standards, and what we are working with them is applying our autonomic computing and security technology to, like when I build a cloud system on the fly, is this cloud system in compliance with the government and DoD standard, the SP 800 53-151, I believe. So we are basically taking the AIM system technology and says, when I have a cloud system, does this really meet all the government standards? And we're basically looking at all the configurations and all the properties, all the access controls, the control points, and do these analytics that we build for the Anomaly to decide if this guy is in violations or not. Yeah, we are in collaborations with NIST. We've been working with them for 2 years, and my hope is after they approve the budget today, we might be able to resume the collaboration with them in pushing our technology to the standard community. Yes.
Once again, great to hear that, because those couple examples there. I mean, I think from various folks that we've talked with, I've seen instances where that configuration management is a big issue in and of itself. That right there, system's not configured properly to start. Right away, you lead to problems. Are there ports that are left open that shouldn't be open? Is everything closed down? That needs to be closed down. So, if you've got things that can, help the IT person, do the job more efficiently and effectively, these are the kind of technologies that we're going to need in the future. So, once again, great stuff, and thank you for taking the time to to share your share your expertise with us, and let the community know what you're working on, what you're up to, and thanks for spending the time with us. We appreciate it.
Okay, thank you, Steve. And again, if you have any questions, comments, please contact me. I will be happy to provide you with the information you need. Thank you very much.
Okay, folks. So if you do have any more questions for Salim after the fact, you can either send them to him directly, or you can come to use our tech forum or our info@csiac.org, and we'll get you the we'll get in touch with Salim and get you some answers to your questions. So I wanted to thank everybody for joining us today. Just give you a heads up, we don't have the specific date yet, but it's probably going to be in the last week in April, and we'll be looking at cybersecurity for critical infrastructure protection. That's our target topic, and like I said, last week in April. But as soon as things firm up and dates get nailed down, we'll send out a message to let you know that, and hope to see you again next month. So have a good one. Thanks. Bye-bye.